Good morning, everybody, and welcome to the webinar that we are hosting about Autodesk Civil 3D 2022 and its integration with BIM Collaborate Pro. For those of you that know, we've got a great package in the Autodesk stable called the Autodesk Construction Cloud. It is a cloud-based solution from where we can collaborate from anywhere on the planet as long as we are connected to the internet. And this also extends to a large extent to the Autodesk Civil 3D platform, which is a platform that is concerned with the infrastructure design and development. The Autodesk Construction Cloud, you will find a lot of information online about. If you'd like to browse that, you may see, I find it especially useful to have a look at all products, which you'll find under all products. And there you will find the specific item that we are looking at today. So the platform that we are integrating into is the Autodesk BIM Collaborate Pro, really, is the correct platform to look at. The Autodesk BIM Collaborate Pro platform, and that allows us to co-author models on the internet. It is different from BIM Collaborate in that it also allows you to collaborate with your Civil 3D and share data shortcuts. That's the big one. So a lot of things are happening. There's a lot that is happening on the cloud. It's developing quite quickly. And then the Autodesk Civil 3D, about that is the platform that we are looking at. And this is used for civil infrastructure, for corridor design, bridge design, railways, etc. So how do we go about using the two packages together? How do we go about using the Civil 3D and the cloud together with each other? So looking at our itinerary today, we've slideshow there. We are looking at how do we go about saving a Civil 3D model onto the cloud. What we should think about when we choose a coordinate system, especially for South Africa, other places that might also be of interest to those of us operating from within South Africa would be Yemen. Some of our clients have worked there, in Vietnam and in Mauritius. Yemen and Vietnam, because they also swap the X and the Y coordinate systems, just like we do in South Africa. And then Mauritius, because they often use a very specific coordinate system, which can be problematic if you want to work between different software. So it might be advantageous to choose a different coordinate system there. Publishing Civil 3D topography onto the cloud, that's a relatively simple exercise. Due to time constraints and because the files do take some time to process, I will be demonstrating some of the capability of the software by virtue of an example, and you can see how that works. Then linking a Civil 3D model into Revit from the cloud. Strictly speaking, that isn't something that is done automatically. Revit doesn't understand how to interpret Civil 3D surfaces or alignments and so on, but there are ways that we can manage that, and we'll have a look at that. Then we can also use data shortcuts to save that onto the cloud, and that really is the essence of the collaboration part, the co-authoring part that's available within Civil 3D. Just like on a normal plan, we can use the same workflow on the cloud. So for those of us that would think that you can have a Civil 3D file and have more than one person working on that file at the same time, that is not possible. But what we do have are data shortcuts, and those we can leverage just like we would leverage XREFs in a normal AutoCAD. Then lastly, we can also do clash detection using Civil 3D. And again, we'll be discussing some of the methodologies that we can use on that front. Excuse me. And then finally, we will just have questions and conclude. So first off, how to save a Civil 3D model onto the cloud. So the first thing to do, besides having the cloud activated, you can see over here we've got our Autodesk Cloud active. In here, what we've got is a project that was created. And within that project, we have different modules, depending on which modules you've bought. Specifically with the Collaborate Pro, we'll be getting the document management module, as well as the design collaboration module and the model coordination modules. Those three are the important ones that you would need to have. But in addition to that, if you are the account admin or the project admin, you'll be able to invite users, and these are bring your own licenses, so you can invite other guys from other companies to come and work on your project. And you will see that we've got our members, for instance, there we've got some members, and these guys are all invited to the party. They can come and work on this hub and come and work on our projects. Beyond the members, the companies and the setup of the users, then the permissions are the next phase of the project where one needs to pay attention. So one would have a look at, say, for argument's sake, the documentation or the document management part of things. And there one can set up permissions. And once again, this is something that the hub manager or the manager would manage. And it's pretty simple. You can see it at the top next to project files there. You dive in further into the tree, and you can have a look at your permission structure that you find on the hub. And you can set these permissions as required. This is a typical project where I've just invited a bunch of guys to test the functionality of the software out if they want. So everybody's got full permission, but it wouldn't be like that in a normal situation. You would make sure that you've got the correct permissions assigned to the correct users, depending on what they need to achieve. And then one of the further things just for setting up the hub is setting up our teams. I've got some teams that I've created over here and some extra folders. This is quite an old project. I would structure the project differently today, but there you can see what it is. And then lastly, on the shared folders, this is a sort of unilaterally shared platform where one can do clash detection and so on and so forth. But so this webinar is not so much about the cloud as it is about Civil 3D, but you would need to have this sort of structure before you can start saving your files onto the platform. Another thing that you should do is you should also install the Autodesk Desktop connector. It's different from the Autodesk Desktop app. The Autodesk Desktop app gives you your available updates that you can do. You can see that blue and green A there. And then I've also got another A, which is a white A. And that is the Autodesk Desktop connector. It's very easy. You can download it. And if you want to update it, it will even send you updates that you've got. And you can also stop the service right here from that A. That is the method you would use to update that service. But in any case, what that does is it sets up a Dropbox type of environment on your hard drive. So you would have to have enough space on your hard drive, obviously. But in your username, you'll see on C drive users, in my username, there's the ACC docs folder. And within here are the different platforms or different hubs that I've got working. And then we've got the MG Storm, that's where I'm working. And there we find the project that I'm busy working with. So within this project, the folder structure that we've just seen on the cloud is replicated. The files that are stored within these folders are only available for 3 days if you go offline. You can do that with this platform. Right-click and say you can work offline. And what that does is it disconnects whatever files you've synchronized onto your computer. You can at any time right-click on a folder and synchronize a file to update it. So it stores the file name, but not necessarily the information beyond 3 days unless you've synchronized it. So it's not going to store an enormous amount of information on your computer. Some of these folders can get very big, gigabytes and gigabytes and gigabytes of memory. And so it's a nice way to manage these files. And within here, you'll find teams, and within your teams, you'll find the files that you are working with. You'll see the name there, and then also the status of this thing. Currently, I've got one of the files open. You'll see there that we've got the Civil 3D file open, and it's got a checkmark next to it and a lock. That means I've got it open, and that is opened by me. It's locked by me, and I'm busy working with that. So you wouldn't be able to work with that. So they've built that locking functionality into the software onto the cloud so that more than one person at a time would be able to change that file and overwrite each other's work or take ownership of a file when somebody else is busy with it. But in essence, with Civil 3D, only one person at a time would be able to open that file. Note also with these projects, just something to keep in mind when you do use these projects is that with Revit, the first synchronize that you do onto the cloud, that will be the version in which the project is initiated. If it is a later version than the version that somebody is using on your project, then you will not be able to revert to an earlier version. Makes it easy for Revit users to understand because Revit is not backwards compatible. And in the same way, these cloud projects are not backwards compatible. You can always upgrade or update a project onto a newer version of Revit, but you can't go back onto an older version of Revit. To make 100% sure that when you initiate your first file on your project, that it is within the year that you would like to work. And that's important because especially if you go further with this workflow and you use InfraWorks, for instance, all the software that comes into InfraWorks must be of the same version as well. So if you are using 2021, this hub isn't 2021, you can see I've actually named it as such. That helps me to understand from the get-go which version of the software I should be using on this hub. So that would be a recommendation for you. Always use or include the year or version of the software you would like everybody to use on this hub, and maybe state that within a BIM protocol. That would be a good idea. So once you've got all of this constructed, it will become available for you to browse within Civil 3D. Now, it does take some time to synchronize these files. You can see it's 60 megabytes onto the cloud because the cloud processes this file first. And for that reason, I'd like to show you that we've got when you open a file, there's two ways to do that. You just say open the drawing, then you would be able to choose your BIM 360 hub from over here. Actually, directly. And really what this is doing is pointing towards the file that's synchronized on your hard drive. It just makes it look as if you're working directly on the cloud. So it is a disconnected data set. And within there, you will find your project files, your folders, and within these folders, you'll find the files that you're working with. For instance, a work in progress BIM. Here we find the GX, the geomatics, and there we can find the file that we can work with. And then we can open it just like that. Whatever I'm saving from here onwards onto my hard drive is going to get saved back onto the cloud. That will then open up within your Civil 3D. If you had already constructed a Civil 3D file, then you would simply do that in reverse. So you say file save as, you will browse to the cloud and then save that file onto the cloud. Right. Here we can see what that file would look like. So if we had to do this in reverse, then we would say file save as. And then within our file save as, we'll be able to save this drawing onto the cloud. And again, we will see our cloud folders available. So that's one of the important things. The next thing that is of critical importance is which coordinate system is it that we would like to choose. Right? So another thing to note is that the files that are synchronized onto your hard drive, maybe omitted to say this, although this is pointing towards your local disk, the file paths that the cloud sees are all common between your computer and some other computer. So the file paths within your XREFs, your links, your data shortcuts, whatever you are linking in will be consistent. And that is in fact something that we do from within Revit, is that whatever CAD files we link in, we link from the hard drive. And we would typically browse to the C drive users and then into the BIM folder and then link it in from there. Earlier, so CAD files should be linked into Revit from the desktop connector. The topographies which are linked directly from the cloud. So you can publish topographies. It's a typical thing that architects would like. We'll have a look at that in the later. Earlier versions can be saved onto the hard drive. So if you have an earlier version of Civil 3D and you'd like to save a CAD file on there, you can do that. It might just not behave exactly like the modern 2021 or 2023 versions. Then with regards to the coordinate system, we can create custom coordinate systems, right, that can work between Civil 3D and InfraWorks. However, they might not always work for Revit. And this is especially true for South Africa, where we swap the X and the Y around. There's actually a country kit force for Civil 3D. We can choose this coordinate system, the transform that we use. And similarly, you can set that coordinate system up in something like InfraWorks, but it will never work for, well, not never, but it currently does not work for Revit. So you might consider using a right-hand rectilinear coordinate system where the X and the Y are not swapped, so that you can say, for argument's sake, bring the topographies into it. Then some special custom coordinates do not work between InfraWorks and Civil 3D. Now, I came across this when I was investigating a Mauritius coordinate system that is typically specified within Mauritius. And I downloaded a file where somebody's gone to some trouble to set that coordinate system up. It's got an offset from the origin and it's very specific. And while one can open a Civil 3D file to see those coordinate systems, they are not readily available. The interoperability between Civil 3D and InfraWorks, for instance, does not work. Right? So again, understanding the limitations of the software that you are using, whether it be Revit, Civil 3D, or Civil 3D and InfraWorks, either or, you need to understand that there are some limitations with regards to the coordinate systems. I always mention this to people at the beginning of the project. I mention this to the BIM managers so that they understand that the choice of coordinate system will be important and they might consider something else. What makes it tricky is some of the coordinate systems that are available for a country might not be as accurate. Transform might not be that accurate as what they require on the project, but that depends on the project. And then the last thing over here is you can also export the coordinate system to operate in Revit as a shared coordinate system. So this is currently built into the 2022 version. In the 2021 version that I'm working with on this project, you have to install an additional item from the Autodesk account. And you would simply go to your Civil 3D platform in your account, download and install that app. We can show you how to do that quickly. And then once you've installed that app, you'll be able to use the export of a coordinate system. In 2022, that's already been built into the software, so you don't have to worry about installing anything. And so that would be a very easy thing to do. Once your products are loaded, you'll be looking at your Civil 3D. You will view your downloads, updates and add-ons. And then you will search over here for the shared coordinate extension that you can install there. Shared reference point for Autodesk Civil 3D 2021. That is what you would look for when you install it. It's quite small, it's 4.3 megabytes. And once that is installed within your Civil 3D toolbox, you'll see that it installs from your subscription extension manager the Autodesk shared reference points for Autodesk. Now, the origin of a Civil 3D project might be very far away from where the project is modeled. That's because of the survey beacon. And it does become relatively tricky in Revit to set that up to start with. But to have this thing work, you need some geometry within the project that is common to both the software and the Civil 3D. Right. So you can see how far the origin is away from the project. That's the survey beacon down there below. I switched off the imagery beyond what I put, and there we can see the the project as it is. And within here, we have the topography. Right. So what I've done in addition to this is I've set up two views, which you can see on the first sheet that will open. Because there are two sites that I want to consider over here, there I've indicated a point to insert onto Revit, as well as a grid line with a label giving me the X and the Y position with reference to the survey beacon. So that's for one of them. And then for the other one,